everybody. We're ready for our last conic today. So we've done circles and ellipse and hyperbola, and today is parabola. And obviously you know that you've heard the word parabola before. We certainly studied them when we studied quadratics. But when we think of them in a conic section, we're going to think about not only the ones that are functions, but the ones that are not functions. So let me just do a quick little review and show you a couple things. Okay? So when you think of a parabola, I hope you think of the most basic parabola of y equals x squared. I hope you then remember the key points that we had you memorize from the beginning of the school year. So we would do 1, 1, 2, 4, right? And so that was our basic parabola, right? And within that basic parabola, we had a coefficient of 1, okay? And if that parabola were to change its coefficient, okay, so let's say that we were to put some other number in front, right? And so we use a variable like a. A could be positive, in which case it would still open up, but it might be skinnier, it might be wider. And so what I want you to always remember is that at the end of the day, you know that when you have a y, and specifically an x squared, that it's what we call a vertical parabola. And it's called a vertical parabola because it opens up or down. Okay? So if you think back, there was a time that we would do inverses. And inverses is when we changed the x and the y. Okay? Now you could have a coefficient here as well, right? And we're going to continue to call that coefficient a, but I'll be honest, the a from the red equation and the a from the blue equation are most definitely not the same. Okay? So there's just a coefficient here, and we'll give it some random letter that we haven't already used. Now, if we have x equals y squared, that can't be a vertical parabola. Instead, it has to be what we consider to be a horizontal parabola. So what I like to kind of intro and focus on at the beginning is you already should know which one is vertical, because the vertical one opens up or down, and we're used to that one because we've been working with that one since you were in Algebra 1. And the new one, the horizontal parabola, one that, for example, might open to the right, is a horizontal parabola because it opens left or right, in this example, right. Alright, so now there's a definition that I want you to take a moment and pause and write down. So pause the video so you can write down that a parabola is a set of all points equidistant from a fixed point, the focus, and a line, the directrix. Now, one of the things that you want to know about these two components to the definition, about the focus and the directrix, is neither of those, the focus or the directrix, was ever talked about when you learned it in just a simple quadratic. You didn't talk about the focus, you didn't talk about the directrix. And so those are new pieces that are going to come into play and will be a part of both our answer and our conceptual understanding of where a parabola comes from. All right? Now, as we start to look at this opening page, you see all kinds of fun. So what's going to happen is, in a moment, I'm going to show you a labeled one of these, and we're going to kind of talk about where all these pieces came from. All right? So one of the things I want you to start by looking at are, what are the key things? Well, we have a vertex. We know that's going to be important. We have a focus and a directrix, which Ms. Olson just talked briefly about in the definition, right? Focus and directrix. And then you have an equation, and then you have which direction it opens, left or right. And so down here you have vertex, focus, directrix, equation, and how it opens. And the key is, which of these is the more familiar case? Well, since the more familiar case is the vertical one, I'm actually going to start with it. And so what I want us to remember is that if the vertex is HK, no matter whether it opens up or down, we want to identify that piece. So that piece, just to be clear, right here is called the vertex. So we'll give it a V. Okay? Now, the focus, if it's opening up, seems to go in a positive direction from the K. And so this point must be the focus. Whereas if the parabola is opening down, as you can see in the second example, so if it opens down, you can see that the focus seems to be subtracted from the K value. And so that makes sense because the focus has to be inside. Okay, the focus, just like in a hyperbola, it's inside the branch. The focus in a parabola is also inside the branch. So that is some consistency which we can appreciate. Now the directrix, we said earlier, was a line. So if you come back up here for a quick second, the directrix is a line. So when I'm looking at this graph and I'm trying to ascertain what do I think the directrix is going to be, I'm going to argue that this line right here that I'm tracing in red is going to be the directrix. Now, one of the things I want you to notice is that this directrix in this parabola, okay, is a horizontal line. The directrix when it opens down is also a horizontal line. And in case you forgot, when you label a horizontal line, it's always going to be y equals, and then some number, okay? Well, how do you know what that number is? Well, that's the cool piece that kind of links these things together. And if you look, the focus compared to the vertex is a distance of p. So, the distance between the vertex and the focus is p. But the distance between the vertex and the line is also p. And so what we want to know is that this, whatever count you go towards the focus, you're going to go in the opposite direction to figure out where the directrix lies. And that's true in any case. So if you go down for the focus, a distance of p, you'll go up a distance of p for the directrix. Now, how does that compare to our horizontal parabolas? Well, once again, you see h and k as our vertex, so that's nice. That hasn't changed. You see that the focus is inside. You can see that the distance between them is a distance of p. And then you can see that you also can count p the exact opposite. So if I went left for the focus, I go right for the directrix. But one of the things I want you to definitely pay attention to is this idea that the directrix line is no longer a y equals. It's a y equals when you're dealing with a vertical parabola, but it's an x equals if you're dealing with a horizontal parabola. And that's really just because it's a vertical line. And vertical lines have x equals as their equation. Alright, so horizontal parabolas have an x equals equation for their directrix. Vertical parabolas have a y equals equation. Alright? Now, similarly over here, we could still label things. We could label it with a V, an F for our focus, and we could call this the directrix. Okay? This distance of p is still allowed. Now there's one other thing that if you're carefully noticing these notes now near the bottom, you'll see another definition. And that definition is for something called the focal chord. Okay, and so the focal chord, it says it's a line segment. So segment means it starts and stops, in case you forgot that from geometry. It contains the focus, which means it goes through the focus, and it's going to be parallel to the directrix. So I need something that's parallel, for example, to this horizontal line, and it needs to go through the focus. So I'm going to go from one endpoint of the parabola to the other, and that whole segment right there, that whole thing is called the focal chord. Okay? That whole blue highlighter piece is your focal chord. Okay, it says it has endpoints on the graph. So if we come up here and maybe take advantage of our second graph where we have less written, we can draw a segment from one edge of the parabola to the other. This parabola should probably have an arrow to keep going. And this whole blue segment is called the focal chord. Okay? It goes through the focus, starts and ends on the parabola. Now that focal chord is in a very special location, and as we learn more about graphing on the next page, we will continue to kind of talk about where that comes from and how to work with it. Now there's one final thing that we want to make sure that we are addressing before we leave this opening page of our notes, and that is that we want to talk about the coefficient and the general equation type. So when I started with these notes, one of the things that I drew attention to was that we already know y equals something x squared for vertical parabolas. Okay? So if we come here to our vertical parabola, I want to compare this generic equation that we're already comfortable with the current equation. And so I see that it starts with a y. I see that the x is going to be squared. You can see there was an adjustment. So this is when the vertex is at 0, 0, and here's our adjustment for when it is somewhere other than 0, 0 for the vertex. And you're going to see and notice that this coefficient is no longer an a in a generic sense, but we've given it something more unique. We've said it's 1 over 4p. Now that's going to be a positive value when the parabola opens up, and that overall coefficient will be negative, but with the same fractional relationship of 1 over 4p. Now I haven't defined what p is formally yet, but just as a reminder, we've kind of talked about it here. P is the distance from the vertex to the focus. And so that might not be a bad idea for you to take a minute to make sure that that gets written down. So I'll write it off to the side. P is the distance from the vertex to the focus. So we no longer have A, B, and C the way we do with ellipse and hyperbola because we don't have a center. Plain and simple. We have a vertex. So again, the key pieces are vertex, focus, directrix, but we also are going to be concerned with this distance of P. Okay, so P is the distance from the vertex to the focus in a parabola. All right, that's our opening piece. We'll get to some examples in the next video.